So today we're working with a problem looking at a particular amount of something um, through a chemical reaction makes a particular compound in a given quantity. And the goal is to basically tweak the reactant and then figure out the mass of the compound. Now, what do I mean in this case? Well, if you see here, we have a particular amount of sulfur. We have 0.312 grams of sulfur. And we know how much sulfur dioxide that produces. That would produce 0.623 grams of sulfur dioxide. If we tweak the amount of sulfur used in this chemical reaction, how much sulfur dioxide would we have? So really, there at the heart of it, there's several ways to do a problem like this, and it requires ratios and proportions, and maybe even a little mental gymnastics. But these questions can be approached in many different ways. But at the heart of it, we're doing the same thing. So, first let's reduce the amount of information that we have when looking at the question. You can see there's a lot of other words there, but ultimately what we want to do is we want to figure out what we're given and what we're being asked for. So in this case, we're given 0.312 grams of sulfur makes 0.623 grams of sulfur dioxide, right? Because it's dioxide because we have two oxygen atoms. So although it doesn't say it, somewhere in between that reaction between sulfur and oxygen, or sulfur, somewhere in between that reaction to get sulfur dioxide, we had to use oxygen because it's sulfur dioxide. There's oxygen in the compound. So, it's sort of giving you this very cutthroat proportion that this much sulfur gives you this much sulfur dioxide, but it's your job to understand that oxygen was used somewhere. So this much sulfur gives you this much sulfur dioxide. And then it says if I tweak the amount of sulfur, if I go from this much sulfur to 1.305 grams of sulfur, how much sulfur dioxide would I have? And that's at the heart of the question. So let's go ahead and first explore one approach, and then we'll explore different approaches, maybe approaches that are a little more efficient. But in this case, we recognize that we needed two reactants to have a final product that contains two reactants. We needed sulfur and oxygen to get to sulfur dioxide. So, it helps to just write it out and then build pragmatically what your approach would be. So 0.312 grams of sulfur plus a particular amount of oxygen, right? And you don't know how much oxygen was used. We can let that be X. So X amount, X grams of oxygen equals 0.31, or actually 0.623 grams of carbon dioxide. So this is what we're looking at, and this is what happened in the first situation. And you'll immediately notice that algebraically you could solve for how many grams of oxygen was contained or was used in this chemical reaction by some basic transposition. So you could say that X grams of oxygen equals 0.623 grams of SO2 minus 0.312 grams of sulfur dioxide. And this makes sense because if 4 plus 3 is equal to 7, then, or actually if 4 plus x is equal to 7, then x will equal 7 minus 4, which is 3. So that's sort of the approach that we have here. And we're just trying to figure out, what happened in our reaction. What's the information that we can extrapolate and use in order to, again, build that pragmatic approach. So the X amount of grams of oxygen equals the subtracting the sulfur from the sulfur dioxide, and we'd subsequently get 0.311 grams of oxygen, right? X amount of grams of oxygen equals this much. And therefore, the 0.311 grams of oxygen was used. So if we look at what we have in total, well, 0.312 grams of sulfur plus 0.311 grams of oxygen eventually in the first situation made 0.623 grams of sulfur dioxide. But of course, this doesn't answer our question. It only gives us information about what happened in the first scenario. It doesn't tell us, well, if we were to tweak the amount of sulfur, how much sulfur dioxide would we have? And you know, what we would want, I mean, this is the first situation, right, where it didn't give us the amount of oxygen. We solved for the amount of oxygen. But if you look at the second situation, if you look at what we have in the second situation, again, we're looking at what we have. If you look at the second situation, we're told that 1.305 grams of sulfur, so 1.305 grams of sulfur added to, again, some amount of oxygen makes some amount of sulfur dioxide. Now, that's not a lot to work with. Clearly, an algebraic approach is not going to work here. And that's because, you know, we don't have two of the three values, right? Up here, we had the sulfur and we had the sulfur dioxide. But, you know, we don't have two of three values here. We don't have oxygen. So at the heart of the first approach is to figure out how much oxygen there was, and the addition of the sulfur and the oxygen in the second situation will ultimately equate to the total mass of sulfur dioxide. So let's figure out how much oxygen there was. And how do we do this? Well, if you want to figure out how much oxygen you need for a particular amount of sulfur, that's what we're doing in the first situation. We're looking at this much sulfur, how much oxygen do I need to make that sulfur dioxide? We have this information in terms of its proportions in the first scenario. In the first scenario, we're told 0.312 grams of sulfur makes 0.311 grams of oxygen. This is a proportion. For every 0.312 grams of sulfur, I'll need 0.311 grams of oxygen to make sulfur dioxide. So you can put sort of a proportion here and work with that proportion, and I'll show you how. So we have 0.312 grams of sulfur makes needs 0.31 grams of oxygen. And that is our proportion for this chemical reaction. And this proportion works, but we want to have it in terms of 1. So if you want to figure out how much any amount of sulfur makes in terms of oxygen, you want to first figure out how much 1 gram of sulfur makes in terms of oxygen. You can use that. That's information you can use. So in this case, we have 0.312 grams of sulfur makes this much oxygen, but we want it in terms of 1. We want the ratio in terms of 1. Well, how much does 1 gram of sulfur make? So what you do ultimately is you can divide both sides of the ratio. And again, we keep the value the same if we divide both sides. We don't change the amount. I could divide both sides of this number with both sides of this ratio with any number, and the value would still be the same. But I'm going to divide by 0.312 and 0.312 because I want a particular amount of sulfur in terms of 1 to equate to a particular amount of oxygen. So here we would have 1 gram of sulfur equates to, and you would divide this out, and you'd eventually get, let's see here. So you'd eventually get 0.997. So you'd get 0.997 if you had a calculator of oxygen. So for every 1 gram of sulfur, I get 0.997 of oxygen. And that is the conversion factor. Now I could have any amount of sulfur with this proportion. I could change the amount of sulfur and I'll know how much oxygen I'll need. Or I could change the amount of oxygen and I'll know how many grams of sulfur I'll need. This is interchangeable as long as you're precise about the element. You could have said, well, 0.997 grams of oxygen. For every 0.997 grams of oxygen, I need 1 gram of sulfur. This works as well. And so this is how you build it up. And you can use this as a conversion factor. And so now I can change the amount of sulfur and I can get the amount of oxygen. And I'll do that sort of on the side here. So you take what you have, and this is sort of a famous conversion method. You take what you have, which is 1.305 grams of sulfur, and you want it in terms of oxygen, how much oxygen you would need. And so you put the oxygen on the top, so you say 0.997 grams of oxygen, right? That's what you want it to change into. And then you put your grams of sulfur on the bottom so that they cancel out. And if you did it the other way around, your sulfur wouldn't actually cancel out. If you put 0.997 on the bottom and then 1 gram on the top, your sulfur wouldn't cancel out. You'd still be left with sulfur. So this is a famous conversion method here that you can use in order to express one thing in terms of something else. So if we had, how much is 500 meters in kilometers? Well, we know that 1 kilometer is 1,000 meters, right? And so we use this as a conversion factor. So we say, okay, I have 500 meters, okay, and I want my meters to cancel out, and I want to be left with kilometers. So 1,000 meters in this case would just be left with, that's what we would do there. We would, let's see, we would do 5 times 1 divided by 1,000. And that would essentially, and so what you do is you would just multiply this, divide by this. So you'd have 500 over 1,000, and you'd essentially get 1 over 2, which is 0.5. So that's essentially the same approach that we're using in this case. And you can see that if you were to multiply both of this, you would eventually get your answer in terms of oxygen. And so in doing so, you would have to multiply 1.305 multiplied by 0.997. And if you were to do that, you would eventually get 1.3 grams of oxygen. And that's the amount of oxygen that you have, and you can place that here. So you have 1.3 grams of oxygen. And if you add them both, that would eventually equate to how much sulfur dioxide you would have. So so that's about 2.6. So it's sort of a long approach, but it works, and it helps you understand how oxygen fits into all of this. But there is another way, right? There are several other ways to do this, and perhaps those ways are easier. You can see here that in the first example, what we did was we set up a proportion between the we set up a proportion between the reactants. We had sulfur and we had oxygen. And so what we did was we said, okay, well, sulfur and oxygen, we can make a proportion there and then apply that to our second situation. But instead of doing that, what you could do is you can make a proportion between your reactant and your product. So this distinction is very important. The first says that you can make a proportion between your reactants, sulfur to oxygen. The second method says that you can make a proportion between your reactant and your product. What do I mean? Well, I know that for just as I knew that for 1 gram of 0.312 grams of sulfur makes 0.311 grams of oxygen, I know that 0.312 grams of sulfur makes 0.623 grams of sulfur dioxide. And I can use that to sort of get to the same conclusion. So I could say that, well, 0.312 grams of sulfur, for every 0.312 grams of sulfur, I'll have 0.623 grams of sulfur dioxide. That works as well. And of course, you could have it in the ratio of 1 is to something. 1 gram of sulfur is how many grams of sulfur dioxide, and apply that proportion. You could say that 0.312 grams of sulfur you could divide both by 0.12 grams. So you'd be left with 1 gram of sulfur is essentially, and if you were to do this division problem here, you get 1.997. So you get 1.997 grams of sulfur dioxide. So you know the unit value. It's easy to work your way up from there and eventually get how much. If you tweak the amount of sulfur, then you can get correspondingly the amount of sulfur dioxide. It's a conversion factor again. And so we do the same thing that we did here with our conversion factor. So how much sulfur do I have? Start with what you have. You have 1.305 grams of sulfur, so 1.305 grams of sulfur, right? And you want it in terms of sulfur dioxide. So between the sulfur and the sulfur dioxide, which one would you put on the bottom and which one would you put on the top? You're obviously going to put your 1 gram of sulfur on the bottom. So, you'd have 1 gram of sulfur here so that the sulfurs cancel out, and you're left with 1.997 of SO2, which is, of course, your sulfur dioxide. You would multiply both of these, of course, in a calculator. And if you were to do that, again, you would get 2.6 grams. Again, that's just another way of doing it. And you can see how efficient this was compared to the other problem. You don't always need the value of both reactants. If you have just the amount of one reactant to the product, then you can put a ratio that way. It works. And of course, you could think of this in another manner, right? If we're on the topic of proportions, let's go full scope here. We know that 0.312 grams of sulfur makes 0.623 grams of sulfur dioxide. We know that. And the idea here is to set up a proportion with the first and second situation, right? We know that and of course, this is interchangeable, right? So if I were to say 0.623 grams of sulfur dioxide is to 0.312 grams of sulfur, I mean, this is true. If it takes me 0.312 grams of sulfur to have 0.623 grams of sulfur dioxide, then the reverse is true, that 0.623 grams of sulfur needs 0.312 grams of sulfur. Well, if 0.623 grams of sulfur dioxide, that needs 0.312 grams of sulfur. So it works really both ways in this case. And what you can then do is you can of course have it in terms of one, right? How much does 1 gram of sulfur dioxide need? Or again, let's just work with the previous example or the previous situation where it was a little more easier to look at. So let's have 1 gram of sulfur compared to 1 gram. How much sulfur dioxide would that be? So I would divide both sides by 0.312 grams, and I would get 0.623 grams of sulfur dioxide divided over 0.312 grams of sulfur. And if you were to do that division problem, you would get, let's see. So you essentially, let's see here. I guess I could do it in a calculator. So you would get, if you were to do this here, you get 1.99. So for every 1 gram of sulfur, you would have 1.997 grams of sulfur dioxide. So that's sort of the other proportion that we've set up here. And again, you can apply that to the problem. So if you if you have two of these things, if you know how much 1 gram of sulfur makes in terms of sulfur dioxide, then you can find out how much any amount of sulfur would make in terms of sulfur dioxide. So we could set up that proportion again. And we could say that Well, how much sulfur do you have? I think we had 1.305, right? So 1.305 grams of sulfur, and you would want your sulfurs to cancel out. And so you would do 1 gram of sulfur here. Your sulfur would cancel out with sulfur, and you'd be left with 1.947 grams of SO2. So you'd multiply both of these guys here, and of course you would get 2.6. Right. So you could just make, again, you could make a ratio between the products, the reactant to the product instead of just the reactants. So let's just actually confirm that there, that 1.305 multiplied by you would have 2.5. Okay, something around that. 1.947. I think it was 1.99, right? It wasn't really 1.94, it was 1.99, and we would get 2.6. That's one way. Now you could take this same proportion that we had, 0.312 grams, and this is just another way. Is 0.312 grams and then 0.623 grams of sulfur dioxide. You could just say that, okay, well, I know that for that 0.312 grams, I'll have sulfur. And of course, a ratio, A is to B, is just A over B, right? So 0.312 grams of sulfur divided by 0.623 grams sulfur dioxide equals, right? And so this is like the information about the first situation. Then your information about the second situation would be on the right-hand side. So you know that this much amount makes this much sulfur dioxide. Well, how much would 1.305 grams make? You know it's a proportion, 1.305 grams of sulfur. How much would that make? That would make an X amount of grams of sulfur dioxide. And then you just solve for X in this case, right? So since it's a proportion, you can cross multiply. And so you could say that X grams of sulfur dioxide multiplied with 0.312 grams of sulfur would equal 1.305 grams of sulfur multiplied to 0.623 grams of SO2. Then to isolate the X, you could say that X amount of grams of sulfur dioxide would equal to 1.305 grams multiplied by 0.32 or 623 grams divided by, of course, this guy here, which is 0.312 grams. And in doing so, you would in fact get, let's see, 1.305. You would in fact get 2.6. So that's just another method. So throughout all of this, so this first method here was a little too tedious. This method here really sort of reduced the amount of work that we had to do. So it really depends on whether you're making a ratio. You really want to figure out what you want. If you wanted oxygen, then you want to first figure out, well, how much sulfur does oxygen require? How much oxygen does sulfur require? Make a proportion that way, make a ratio. But if you go from reactant to product, then you're going to eventually have a conversion factor which involves the product. And so you'll be able to express your sulfur in terms of the product, which in this case is sulfur dioxide. And so that's really how you would do. It's really how you would do these. But I will add that this whole conversion factor thing, you could do something else in the place of that. If you wanted to say, okay, 1 gram of sulfur makes 1.997 grams of sulfur dioxide, you could say that, okay, well, 1 gram of sulfur makes 1.997 grams of SO2, right? And then equate it to the second situation, which says, what if I had 1.305 grams of sulfur makes how much sulfur dioxide, right? X grams of sulfur dioxide. And in doing so, you could solve for X grams of sulfur dioxide, right? You would just cross multiply, would be 1.30 1.305 grams of sulfur multiplied by 1.997 of sulfur dioxide, which we said, I think we did that multiplication problem somewhere. That would definitely come out to being 2.6. So that's another way. So this conversion factor thing is just, you could make a proportion, or you could make a proportion, or you could equate one situation to the second and have one as X, or you could use the conversion factor. It's really flexible in that regard. So that's how we would do it.